Classes in Python are often seen as blueprints, templates for creating objects, but this view is incomplete and misses a fundamental architectural layer. A class itself is an object, and like any object, it must be created by something. That something is a metaclass. By default, it's the type metaclass, which quietly constructs every class you define. Think of it as the factory that builds class factories. It governs the very creation process of a class object, dictating its attributes, methods, and even its name, before any instances are ever made. When you write class myClassPass, the type metaclass intercepts this declaration. It takes the class name, its base classes, and its dictionary of attributes, then returns a fully formed class object. A custom metaclass allows you to inject your own logic into this interception, empowering you to modify, validate, or even generate class members programmatically during class creation. Consider frameworks like Django's ORM or SQL Alchemy. They leverage metaclasses extensively to build declarative APIs. When you define a model with fields like name models, char field, a metaclass is working behind the scenes. It automatically inspects these field declarations, creates database schema representations, and even injects methods like save or delete into your model class, all without you explicitly writing that boilerplate. It's a powerful form of aspect-oriented programming applied at the class level. This goes beyond mere class decorators or inheritance. Class decorators modify an already created class. Inheritance defines what a class is. Metaclasses, however, dictate how a class is brought into existence. They offer a level of control over the object model that is simply unattainable through other mechanisms, allowing for highly expressive and structurally consistent APIs. However, with great power comes complexity. Metaclasses can introduce a layer of indirection, making code harder to debug or understand for the uninitiated. Their judicious use is crucial, typically reserved for framework development or domain-specific language creation, where strict structural enforcement or automated code generation is paramount. Misuse can lead to magic that obscures rather than clarifies. Ultimately, understanding metaclasses reveals Python's profound flexibility, its capacity for truly dynamic object modeling. They are the hidden architects, enabling sophisticated abstractions that transform mere code into elegant self-configuring systems, allowing developers to define what they want and trust Python to construct the how.